In our earlier section, we have discussed what is reliability, what is maintainability. In this section, we will discuss about manufacturing process reliability matrices. Different matrices that define the manufacturing process reliability or used in benchmarking process reliability will be discussed in this section. The major matrices are tabulated here. They are known as overall equipment effectiveness or OEE. Also, another important matrix is total equipment efficiency or total effective equipment performance. And while calculating these two terms, we need to know some four other terms which are known as availability, uptime, downtime, and idle time. We will discuss all of these matrices in detail and we will validate our knowledge with a practical problem. So first we will discuss OEE or overall equipment efficiency or effectiveness. This is a measure of equipment or asset performance based on actual availability, performance efficiency, and quality of the product or output when the asset is scheduled to operate. It is expressed in percentage. So what are the objectives? Objective is this metric identifies and categories major losses and reasons for poor asset performance. It provides an basis for setting improvement priorities and beginning root cause analysis. OEE also fosters cooperation and collaboration between operations, maintenance, and equipment engineering to identify and reduce the major causes of poor performance. Another thing we should always remember that maintenance alone cannot improve OEE. So these objectives or these points may not be very clear to you at this point, but as we go through the formulas and derivation of OEE and take a practical example, all these issues will be clear to you when you can appreciate these objectives. So what is the formula for calculating the overall equipment efficiency? It is availability multiplied by performance efficiency multiplied by quality rate. All three are in percentage. Now what is the availability? Availability is uptime divided by total operable time or total time it is available to operate, which can be also denoted by total available time minus idle time. Then what is the uptime? Uptime is total available time minus idle time plus total downtime. So the idle time you can see that idle time is not a uh, not a problem of maintenance department. It is basically the time when the machine is not allowed to operate. What the maintenance department is concerned about is total downtime, that is scheduled downtime plus unscheduled downtime. Scheduled downtime when you do the scheduled maintenance and unscheduled downtime is when you do the corrective maintenance. Again, what is the performance efficiency? Performance efficiency is actual production rate divided by best production rate. Suppose you have a machine and it is designed to produce 167 nut bolts per hour. Now, if it is producing 100 nut bolts instead of 167 nut bolt, so the actual production is 100 and the best production rate is 167. Next, what is quality rate? Quality rate is total unit produced minus defective unit produced divided by total unit produced. So when you run a machine, it may not be case that all products are absolutely fine without any defect, but it happens in practicality that some of the product may be defective and that cannot be sold or cannot be used. So quality rate is basically number of sellable or good unit produced divided by the total unit produced. So we have learned what is availability, we have learned what is performance efficiency, and we have learned what is quality efficiency. So if we multiply these three things, then we will get the OEE, or overall, we will get the overall equipment efficiency. So this is this is the practical problem I have tabulated for you, and this will hopefully clear your doubts and it will further boost your knowledge or reduce your knowledge gap. Suppose you have a machine and we will be calculating OEE for a day, in this case. Now as you can see that I have given the total available time. As we are considering for a whole day, we are considering total available time as 24 hours. Now within these 24 hours, idle time is 8 hours. This is the time when it is not required to operate. There may be multiple reasons. Maybe the plant is designed in such a way that at night time it does not operate. So the night time 8 hours or 8 hours it is does not operate, so it will be a idle time. I can give you an example like a printing machine, newspaper printing machine. What happens that they normally do the printing only in the night shift, maybe last 8 hours, maybe from night 8 p.m. to morning 3 or 4 a.m. the machine runs, or all the other time, that is from morning 7 a.m. to the evening 7 p.m. the machine is in idle. So that is not because of maintenance issue, that is because it is not required to operate at that time. Okay, now we will discuss various scheduled downtime. Scheduled downtime may be due to the shift change. Okay, note that this 0.66 hours, this is also not attributed to maintenance. Second is plant maintenance 1 hour. So total scheduled downtime is 1.66 hours. Now there may be numerous unscheduled downtime, which may be waiting for the operator, which may be failure or breakdown, which may be setup or changeover, or maybe tooling or part change, setup adjustment, input material flow. So adding all these things, we get the total downtime, and total downtime is around 2.08 hours in this case. Total unscheduled downtime. Now total downtime will be scheduled downtime plus unscheduled downtime. This E value, E is equal to C plus D. E is equal to C plus D. Okay. Then what is the uptime? Uptime is total available time minus the idle time minus the total downtime. This is the uptime. This is the time when the machine is actually live. Machine is actually on. Machine is actually doing the production. So uptime is 12.26 hours. So what will be the availability? Availability formula we have uptime divided by total available time minus idle time. So this comes out to be around 76%. So this way we calculated the availability. Okay, I hope up to now it is clear. Now we will calculate the performance loss. We may consider that there is no minor stops. Design speed is 167 and reduced speed is 100. That is, the machine is designed to produce 100 newspaper per or maybe it is 100 pages it is designed, the printing machine is designed to produce 167 papers or print 167 papers per hour, but actually it is printing 100 papers. So the performance is down, and performance efficiency is calculated by actual speed divided by the design speed. Okay, now we will discuss the quality. So out of 167 design, we have produced 100 papers. Now say all 100 papers are of good quality, or there are some pages where the color is not coming properly, in some pages are torn. So all these things we have to check. So in this case we 2-3 points we have noted: there may be scrap, there may be defect, there may be transition. So rejected unit will be sum of all these three, which comes out to be 8, number 8. Now out of 100 good units produced, there are 8 is defected. So actually quality wise good unit produced is 92. So what will be the quality rate? Quality rate will be good unit produced divided by the reduced speed or actual speed what you have now into 100. So this we get at 92%. So 92%. So we have three terms now. One is availability, which is 76%. One is performance efficiency, which is 59%, and another is quality rate, which is 92%. So if we multiply these three terms, we get the overall equipment effectiveness, that is 42%. 42%. Now, as you go into somewhat deeper into it, you can find that this 42% uh, against the designed or maybe inherent capability of machine to make it 100%, it is, or you today it is 42% and you want to increase it to say 80%. This cannot be solely done by the maintenance department, because there is various factors inbuilt within it which depends on operation. So rather than dividing the operation and maintenance categorically, we can say that whole unit should try and increase the operational or overall equipment effectiveness. That is why the term overall came. Overall is to denote that both uh, both operation and maintenance is responsible for it. So I am just kept a blank page to do the calculations here. Okay, now this timeline is will further clarify your doubts if you have any. You can see. Okay, so this is the total time available This total time is 24 hours. Now within this time there is some idle time which is 8 hours in our last problem, and there will be some scheduled downtime. The scheduled downtime may be PM or all these things. So if we minus these two terms, we will get the scheduled hours of production. This is the hour in which the production is to happen. But now there is unscheduled downtime due to various reasons, like waiting for the operator, waiting for the tools, waiting for the spares, etc., waiting for the input material. So ultimately the uptime hours of actual production, this is the uptime, this is the time where the actual production begins. But within this time not all the products produced are consumable or can are sellable, because there is some speed loss due to the machine's inherent characteristics or something. So this will reduce from base production rate to actual production rate, which our earlier problem it was 167 and reduced to 100. Now within 100 there will be some quality issues, there will be some bad production. So if when we minus it from the actual production, we get the sellable production. So in our case, out of 100 there are 8 products are there which are quality loss product. So ultimately we get 92 products here. So this timeline is very important, and you can take a printout and fix it in your wall of the office. So this will give you a clear understanding how to calculate the OEE. Okay, now what is the OEE benchmark, or in a world-class plant, what is the value that are being maintained? So for a batch type manufacturing process, this is typically 85% to 100%. For a continuous or discrete manufacturing, it is 90 to 100%, and for a continuous process, it has to be from 95 to 100%. So to achieve uh, 95 to 100% OEE, we need availability at least more than 90%, quality more than 99%, and performance more than 95%. So combining these three, we can get we can expect an OEE in the range of 85% to 100%. So some points we should remember while calculating OEE, because OE percentage is a better measure of a specific equipment. You cannot compare if you have a machine A and if you have a machine B, or if you have a machine A in some plant, and in some plant, in same machine A in some other plants. You cannot compare the OE value directly, because this gives us some wrong calculation. So we need to calculate OEE only at plant level and on a specific equipment only, and we should try to improve OEE or OEE value of that particular equipment. So we should not compare the OEE value between two machines, or between two plants. So it is not actually very good item to do the benchmarking. So OE percentage should primarily used as a relative internal improvement measure for a specific asset. OE not a measure of maintenance effectiveness, since most factors are not within the control of maintenance. So another thing that I pointed out earlier also, that factors that are contributing to OE are not always in control of maintenance. So it is a total department concept. Or if you are running total productive maintenance, it is the matrix that defines that whether your total productive maintenance or operator driven maintenance is working fine or not. Another thing that is of critical importance is, I have shown you that in the timeline that there is a time which is known as idle time. Idle time is the time when the machine is not required to operate. But this time is available with you, and within this time you can do the maintenance. You can do the schedule maintenance. And if you do that, this time cannot be considered as downtime. Suppose your machine is not required to operate from 7 a.m. to 7 p.m. and you are doing the maintenance within this time. So if you are doing the maintenance within this time, it will not be considered as downtime. So one more thing, just a caution that OEE value cannot or never exceed 100% value. So while calculating, you should remember this. So I have attached one Excel sheet where you can just input the values of different scenario. You can put the values of the idle time, you can put the downtime values, and the actual production rate. And when you put all these values, the overall equipment efficiency and availability, production rate, performance, quality, all the terms that we have discussed will be automatically calculated. So you no need to worry about the formula. So you can just download this and can directly use it. So in the next section, we will discuss another important term which is known as the total effective equipment performance.